next thing we are going to talk about is, so what all, let me just walk you through the UI components of the dashboard. Okay. Okay. So let me talk about components one by one. Okay. So the first segregation you are going to see in that dashboard is you are allowed to choose which namespace you want to list the resources. Okay. And also, if you see that on the left hand side, you can see some of the components are marked as namespace. Like for example, the workloads, they are configured as namespace. So they are the output, whatever you are going to get output below the workloads are namespace specific. Okay, it is correlated with the Kubernetes, and service also namespace specific. And here in the configs and store, these three are namespace specific, but storage class is not namespace specific. Okay, it is on the cluster level. Okay, here also under the cluster, some of the components are cluster level, some of them are namespace specific. Okay, so that is what the differentiator on the namespace specific and the cluster level. Okay, first thing is, if you want to choose any namespace, you can choose it, or also you can choose all the namespace. It is going to list all the resources from all the namespaces. Okay, so whenever you want to deploy a pod in the Kubernetes, the first thing you are going to create is a deployment. Okay, so once you create a deployment, it is going to create a component called replica set. Okay, imagine while explaining the like yesterday while explaining the best practices, I told that the Kubernetes has the ability to keep the older versions of the deployment. So whenever there is an issue, I can go back to any previous version, right? So this is achieved by storing the replica set. So for every deployment, a new replica set will be generated. Okay, and based on that replica set, I will be able to roll back. So that is what happens in the history of deployment. So when I create a deployment, it is going to create a replica set, and replica set work is to, for example, in the deployment, I say, I want 4 pods to be running for this particular microservice. It will ensure that the 4 pods are running for that. Okay, that is the work of a replica set, which basically it triggers the pod creation. So when you create a deployment, it will create a replica set, and the replica set will create a pod. This is the correlation between a deployment, replica set, and a pod. Okay, so there is previously people used to use replication controller. Nowadays they are not using it. The problem with the replication controller is I cannot define a node affinity in the replica set. That means I told you while talking about Docker, you cannot run a Windows Docker container on a Linux machine. So when you want to host a Windows container, you need to host it on a Windows machine. Okay. In Kubernetes, Kubernetes is not available for Windows. As of now, Kubernetes is not available for Windows. The only option you can do is you can bring up the Kubernetes cluster in Linux, that is master in Linux. To that you are allowed to add Windows nodes to it. Okay. In that case, I can have a cluster which is configured in Linux, and to that I can add both Linux node and Windows node. When I want the Windows container to be running on the particular Windows node, I will define something called as a node affinity. So I'm saying my pod should be running only on this particular node or particular group of nodes. So this is called node affinity. So this is not possible with the replication controller. That is where the replica sets comes into picture. Very soon the replication controller will be removed or depreciated. Okay, so this is the use of a difference between a replica set and the replication controller. Deployment, replica set, and then pods, and also we have talked about the replication controller.